Right, dear students, look here. Today, this is last video of human eye and colorful world. Here, last few concepts are there. What is that? Some phenomenon based on atmospheric refraction. Some phenomenon based on atmospheric refraction. What are that? Yesterday we seen near sun. One type of layer is there, that is a rarer layer. Below the sun, below the first layer, not rarer, not denser, but medium type of layer there. Near the earth surface, denser layer is there. Denser means which layer containing more particles more than a rarer layer. Air particles are there, but more near the earth surface layer, and air particles are less under the sun, near the sun, first layer. And here, what we are talking now, look here, some phenomenon based on atmospheric refraction. Some phenomenon mean some types of changes are there. How? That is very clear. Look here. Twinkling of stars. Twinkling of stars. How it is possible? Look here. For example, in sky, star is there. In sky, stars are there. Yes. When we are looking in a sight way, for example, with my eye, this is sight line. This is sight line, not straight. Sight line and straight line. Okay, nothing to worry. Sight linear line. When we are looking sight linear line, then our eye can capture its image clearly. This star cannot twinkle because look here, between the sight lines, between the sight linear lines, that star light is refracting. Look here, star light is refracting here to here, here to here, here to here, here to here, and reaching our eye. Our eye have a sight linear line. Our eye have a sight linear line. In that line, when you are looking the star, then star cannot twinkle. But when you are looking not sight linear line, look here, for example, star is here, I am here. For example, eye is here, star is there. Star sight line is this, but when sight line is crossing the refraction, when star's light is crossing, refracting with the help of atmospheric layers. Already I told you, atmosphere is containing layers. From this layer to this layer, this layer to this layer, this layer to this layer. When this line is crossing, here to here, here, here. When line is crossing, then the light of star, then the shininess of star can twinkle. Then twinkle due to refraction of star's light. Due to refraction of star's light, refraction. Many layers are there, not only 3 layers, many layers are there between earth and sun. With the help of all layers, when that star's light is refracting, due to refraction of star's light, we are feeling that stars are twinkling. We are not looking in eyesight. We are not looking of our eyesight. If we look our eyesight, then star cannot twinkle. Example you want? Moon. It is not twinkling. Because moon size is bigger and our eyesight is small. Nothing to worry. Stars are small. Our eyesight is bigger, little bigger. But moon size is bigger. Our eyesight linear is enough, which is not refracting more than eyesight line. Eyesight line, which is refracting more than eyesight line, that type of all stars looks like twinkling stars. Moon is not twinkling star. Yes, moon is not refracting that much because moon size is bigger and our eyesight line is a little small. In that only it is refracting. Enough. Next, twinkling of stars. That is the word. When light from the star passes through atmosphere that mix continuously. So when star is in line of sight, already I told you, star is in line of sight, it is visible. When out of sight, it is not visible. So appear to twinkling. Look here. Why sun is visible to us about 2 minutes earlier to actual sunrise or actual sunset? Why? Look here. Due to atmospheric refraction, this also is said. Due to atmospheric refraction, sun is seen 2 minutes earlier than its sunrise. When it comes close to the horizon, sunset or sunrise, horizon, earth line, for example, think. When that horizon line is in straight way, then we are feeling sun when going to sunset or when sun is comes to sunrise. Then we are feeling sunrise is occurring 2 minutes before, sunset is occurring 2 minutes later, etc. We will feel 2 minutes before because of, look here, atmospheric refraction. Refraction of atmospheric layers are there na. Sunlight when coming or passing through atmospheric layers, then they are not refracting properly. Then they are refracting, more refracting. Due to refraction of earth layers, I mean atmospheric layers, due to refraction of atmospheric layers, sun light is appearing to us. Sunrise is occurring 2 minutes before, sunset is occurring 2 minutes before. That is due to atmospheric refraction. And scattering. One word there, what is scattering? The process is which light is transmitted in all directions. It is incident on a particle which has greater diameter. Look here, very clearly scattering. For example, sunlight falling on the particles of atmosphere. When sunlight is falling on the particle of atmosphere, all the light this particle can absorb first. This particle absorb all the light. Particles are first of all absorbing the light. That after what they are doing, look, what is the diameter d of particle? If diameter d is greater than the wavelength of light, lambda. When the diameter d of the particles is greater than the wavelength of light, lambda, then that particles are scattering, are leaving, are sending the less wavelength particles, less wavelength rays, mean wavelengths which color lights are containing less wavelength of diameter of that particle, that less wavelength containing light colors are scattering, are going from that particle to other sides. Look there, I draw there. Sunlight first of all absorbing with the particles, and particle diameter when greater than the wavelengths of colors. White light containing 7 colors, already we know. When these particles diameter is greater than the wavelengths of colors, I mean less wavelengths, which colors wavelengths are lesser than, diameter of the particles, that colors can splits out from the particle. That is called the scattering of the particles. Thank you.